Hello, my name is Corinne Locker. It is September 11th of 2025. It is week 15 of Organic Chemistry 1, and I am group 21. In group 21, we were assigned to carbon 10, hydrogen 14, and oxygen. I'm going to minimize my screen so we can go over what that looks like. Okay, so again, my formula is right here that I was given. And the first thing I did was I figured out my degree of unsaturation, which I used this formula of 2 times carbon plus 2, and then we subtracted our hydrogen from that, and then we divide that sum by 2. So I plugged in our 10 carbon here and our 14 for the hydrogen. So 2 times 10 plus 2 is 22 minus 14. And then we divided that number by 2, which equals 4. And we will go over where those 4 unsaturated carbons are later on. So I started out by trying to figure out what this chemical formula would be by process of elimination. So I started out with our 1H NMR, because to me that is the best way to figure out what your chemical structure is, because like I put in here, it shows our chemical shift, our integration, our multiplicity, which are splitting patterns, and our interpretation, which is our structures. So that alone would give me most of what I need to know about what I'm working with. And then I used the 13C NMR in the IR spectrum to just verify what I found. So we're going to go up here and kind of go over what we did find. So at about 1.2, we had 6 hydrogen with a doublet, which is our methyl group, which is 2. Then we go down to about 2.8 with a septet, and that is our HR group. CH group, sorry, with 1 hydrogen. At 3.8, we have a singlet with 3 hydrogen neighboring, and it is our methyl oxy group. And then we go down to the 6.9 and 7.4. This is our aromatic ring, or a benzene ring, and they both are doublets with 2 hydrogen neighboring. So that kind of gave me an idea of what our structure would look like. So we're going to go down here, and here's me plugging in all of our stuff that we found. So here's our kind of partial structures here. And then just to make sure that I have the correct data, I went to my 13C NMR, which shows the structural environmental carbons, which there's 7 of in our structures. It does not show the full 10. I found 1 of the carbons, which is our methyl group, and there's this 2 of the carbon hydrogen, 2 of those at about 23 there. And then we have our CH2, which is about 35. And we have our methyl oxy group at about 55. And then we come down to our aromatic ring, which is anywhere from 111 parts per million to about the 160. And those are appropriate for the benzene ring. So all of that is findings that correlate with my 1H NMR. And then just to top it off, to verify everything that we did find and just make sure that there's nothing added or an impure chemical, I went to my IR spectrum. So the first thing I looked at that caught my eye was our spike here at 29, which is our CH stretch, which is what we have. And then I went directly to their 15, about 1500 was our C double carbon double bond to carbon, which we do have in our benzene ring. And then we went to 1300 with a big spike of the methyl methyl group CH3 bending, which we do have in my suspected structure. And then I went to the 1100, which is our carbon oxygen bond bending, again, which is what we do have in our structure. And then our CH aromatic ring, which is about 700 to 900 on our spectrum. So all of that correlates to what I've found. So we're going to go back down here and look at this is my numbers that I've plugged in from all of the spectrums. So with all of that knowledge, I was able to draw out a structure that I believed is correct, which is this right here. So we've got our double methyl groups up here, our CH3s, our CH here, and then our aromatic benzene ring with our double carbon bonds here, which is attached to the oxygen with our methyl group. So this is our methyl oxy group right here. And you can tell above that that is correlating with my NMR, my 13C NMR, and my IR spectrum. So that being said, let's go back to our unsaturated molecules. So we know that we have 4 in our spectrum. So we also know that our usual double bonds are unsaturated. So we have 3 of those double bonds in this benzene ring, and that makes up 3. And the last unsaturation is the benzene ring itself. So there's our 4 unsaturation carbons, which leads me to believe that this is 1 isopropyl, 4 methyl oxybenzene, or otherwise known as 4 isopropyl linosyl. So that is my structure and my formula.